Hello, welcome to this IRIS webinar for the 23-24 academic year. Thanks for joining us to find out more about IRIS's research projects. For those of you who haven't yet signed up with IRIS, you can go to our join page on the website, fill in a few details, and then you'll be put in touch with one of the team who I'll introduce shortly. If you have registered with IRIS already, hopefully this will be a useful recap of how things work and what you're able to do this academic year. So today we're going to give you a bit of background about who IRIS is, what we do, talk through each of the projects, and then talk about where you can find out more information and about our conferences at the end of the year. So this is the team on the call today. We've got Katie, Neil, Richard and Mike, and each of the regional leads has a region, as you may expect, and they also are a champion for some of our projects. So you'll hear from each of them shortly. So IRIS, we are a charity. We launched back in 2016, and we want to change the culture in education so that every young person experiences research and innovation while at school. So one of the ways we do this is by working with researchers in academia or industry to develop project opportunities so that students aged 11-18 can take part in authentic research. And we also support the teachers and the schools running these projects to make sure they've got the advice and guidance to be able to make a success of it. So in the 22-23 academic year, IRIS worked with 104 schools across the UK, supporting 1,492 students to take part in research. Here's a few more numbers from last year. So 87% of the schools that we worked with were state-funded schools and colleges. Between them, they worked on 196 projects. 100% of the teachers that we worked with that filled out our surveys would recommend IRIS to another teacher, which we're so proud of. We're so pleased that teachers really want other people to take this on. Teachers also said that 95% of their students they think had increased their science capital through taking part in an IRIS project. And the students told us that 90% of them know more about what it's like to work in STEM, having taken part in an IRIS project. So a bit about the project. So anyone new to IRIS, it might be useful to hear about the different ways teachers run this in their school. So we designed the projects so they should last across an academic year. A lot of teachers get started in the autumn term and then wrap up in time for our conferences in the summer. Some schools run it across 2 years. It's really flexible. Some teachers run it as part of a STEM club or a research club, maybe after school, and some at lunchtime. Other schools have curriculum hours within the timetable where they can run an IRIS project, or they do some kind of project-based learning where IRIS fulfills that. Schools that are new to IRIS tend to pick one project. You'll hear there's loads to pick from, and maybe run it with a relatively small group of students, perhaps 5, 10, 15 maybe. In future years, it might be you can encourage other teachers at the school to get involved. We've got loads of cross-curricular projects, so you might want to work across science, geography, computing, or maths to run multiple projects with different year groups. So we have 11 projects running this academic year across a range of STEM subjects. Each member of the team, as I mentioned, champions a few of these. So I'm going to hand over first to Mike to tell you a bit about his projects.
Thank you, Katie. Welcome everyone. My name is Mike Grocott and I'm the regional lead for the South. As you can see here, we've got a range of projects, and I'm the project champion for carbon researchers, Treezilla, cosmic mining, Earth observation, and our new project, Future Flight. So now we'll look in depth at each one. So carbon researchers and Treezilla. You will also notice at the top there is an age suitability. That is guidance only, because you know your students better than we do. A-level students could get something out of these projects as much as some of the older aged projects are suitable for able years 8s and 9s, etc. So carbon researchers, as it says, this is a good one, possibly for 8s and 9s, maybe as an eco group or what have you, and they actually do a study of the school's carbon footprint. So they'll run a survey which they design and then use an online calculator to calculate the number of tons of carbon that potentially the school is generating, and then they look at strategies to put in place to try and reduce that, and then they'll run the survey again. This is a great project, as I said, for Key Stage 3, because If they start it in year 8, they can continue in year 9 and 10, so you get a nice piece of longitudinal study into school. Also, it can work quite comfortably with the trying to save energy, and also in terms of climate change and carbon reduction. Treezilla is working with the Open University, who want to measure the tree canopy of the UK. This uses an app or a website, which they can then go out, find a tree, and it is literally that simple. Find a tree, maybe in the school grounds, takes basic measurements, input that data. The tree is then serialized, but it also then gives the students some economic data about that tree: how much carbon it's sequestered, how much water it's cleaned, its value in terms of pounds. So the contribution that tree is making. The more data they put in, canopy size, whether it's disease or not, adds to the actual database that the Open Universities has. They can then, using the website, compare trees across the country, so same species in different areas, and do a bit more of an in-depth research. Our next project that we're going to look at is Earth observation. Now, Earth observation uses Sentinel Hub browser, so it's a piece of web-based software which ESA uses, and from this they can select different satellite images. Depending, the most recent image is usually about a day old, maybe 12 hours, and then they can change the wavelength, so look at different spectrums, so they can investigate their own question, and that's the point. It's their own research. So they learn the skills, which would be our phase 2 part, and then they would implement those skills. Some schools have looked at the amount of flooding in their area over the last 4 or 5 years. Some students look at glacier calving. Others are looking at fires, and there's lots of examples in our library of work that students have done before, including identifying penguin colonies from space by looking at the penguin poo. That was working with Leeds University, as well as funded by the UK Space Agency. The next project is Future Flight. This is our brand new project. This is looking at trying to make zero emission flight. So looking at using hydrogen in hydrogen powertrains, so basically electric engines, and retrofitting current aircraft with those. The key element of this is they need to calculate how much hydrogen would be required to fly a 747 between Bristol and Edinburgh. And not only that, they have to work out, using some 3D modeling software, where they would actually put those hydrogen fuel tanks. And of course, they could put lots of fuel tanks on the aircraft, but then you don't have much space for passengers. So it's very much looking at not just the answer, but an efficient answer. And so therefore a more a viable answer in terms of a business. Very exciting. This is a whole new industry that's now opening up, and students will start working on the ideas and looking at the challenges that will face that industry. And then finally, the next project I'll talk about is cosmic mining. This is working with the James Webb Space Telescope group, who are based at the Royal Observatory in Edinburgh and STFC. In this project, students are trained on how to analyze spectra. A space telescope called the Spitzer Space Telescope took more than 1 million images of infrared spectra of objects in space in our galaxy, and as a consequence, not everyone's looked at those objects. So what the students will do is they'll be trained on how to identify the objects, whether it's a planetary nebula, a forming star, a young stellar object, or something that doesn't fit in with the actual criteria that we're looking at. Once they've got to a certain level of competence, that'll be the phase 2, then we actually give them 50 unknown pieces of data, so images that's not been looked by anyone before. And then once they've analysed that, they're passed up to the James Webb team, who will then look at those results and think, well, these students have identified something as other that might be of interest, and so they will then look more depth at the information that they've got available to them. So it really is looking at data that hasn't been seen and contributing to the work of the research scientists. So they're my projects. I'm now going to hand over to Neil, who's going to talk about his project, starting with DNA origami.
Hi, thanks, Mike. So I'm the regional schools engagement lead for the north of England, and also project champion for the DNA origami and a couple of the chemistry projects. So DNA origami is using DNA as a biological material, but in a very different property to how it would be used in biology and how students learn about it at school. It's an approach to introduce material science to students using a familiar object in an unfamiliar situation. And students will learn how they can design nanomaterials using DNA as a self-assembling building material. So this is an opportunity for students to expand their ideas around subjects they might want to study at university or careers in, that doesn't quite fit into any specific subject. So there's some maths, some science, some coding, along with biology and chemistry. So it encompasses a sort of cross-curricular approach to learning about DNA. Essentially, they can design using a piece of computer-aided design software shapes using DNA as the building material, and they can analyze and assess their structures using other techniques. It's really an exploratory sort of step into material science. The process of DNA origami has only been around since about 2006. So it's an opportunity for them to do something very different that they wouldn't normally do. This project is funded by the Henry Royce Institute and supported by our partners at the University of Leeds, the Bragg Centre for Material Science. So that's DNA origami. The other two projects, and I know Mike's mentioned about our age suitability on previous projects, but these two I would encourage anyone interested in doing these to stick to the age suitability based on the chemicals. So these two projects are variations on the theme of ionic liquids. Both require the students to learn about the properties of these chemicals and also to synthesize them at school. In ionic liquids, which was our original ionic liquid project partnered with UCL, students learn to make one type of ionic liquid and then decide what they're going to do with it. So, for example, ionic liquids are very, very good at dissolving things. They can even dissolve things like carbon. So they might want to look at applications as to what they can dissolve, maybe the physical properties. So they can tailor their ionic liquid by changing the different components of it. So they might want to look at properties or another aspect of ionic liquids and carry out their own independent research. The Ionic Liquids Greener Fragrances project lets them link into work carried out by Queen's University in Belfast at the Ionic Liquid Laboratories. And this project, in its first instance, was funded by a partnership grant with the Royal Society of Chemistry. This one allows students to learn about acidic ionic liquids and how they can be used as catalysts in esterification reactions. These are really clever chemicals that enable reversible reactions to change in how they produce the esters. So we end up with quantitative yields of esters, and the students can then apply some of their direct A-level or equivalent knowledge into a very unfamiliar situation. And there are lots of applications for these in the current media at the moment. Both of these are practical projects, and so I would recommend that these projects are carried out by teachers who are experienced or technicians who are experienced in carrying out practical work. However, if you do have any queries about the suitability, please get in touch. I'd be happy to discuss them with you. Oh yes, I'll now introduce you to my colleague Richard for the remaining projects.
Thanks, Neil. Hi, I'm Richard. I cover the area from Newcastle and through Northumberland into Scotland, over to Wales and also Northern Ireland. So I have three projects, two big data projects, one about particle physics, the Atlas project, the other about COVID-19, and also original research, which I'll come to in a sec. So Big Data Atlas, This is a project essentially about Python coding. We've got an age suitability of 16 plus, but I would say that if you've got good coders with little support for the kind of science element, the physics element, then I'd encourage everyone to have a go. But basically what we're doing here in association with the University of Oxford and the Rutherford Appleton Lab and scientists working at CERN is we have a series of exercises using Python coding where we introduce them to Python. They don't need any prior knowledge. And we progressively take them through various exercises that ultimately leads them to be able to make histograms, to access the data at CERN from the Atlas detector, and then to model that data so that they could find things like the Higgs boson in the data. So it's a really exciting project. We had about 250 students doing this last year, and for teachers who's not familiar with particle physics, I would just say that we have all the solutions. We can support you through the project, so don't worry too much about that. COVID-19 is a project which uses Excel, and if the students want to, there's a package on R, a mathematical statistics software. But basically what we're doing is we're introducing them to the beginning of the COVID pandemic in terms of accessing and modeling the data. Most students stick with the Excel program. It teaches them lots of different ways of using the analysis package within Excel. And then from there, they can basically go and analyze the global database for COVID, make comparisons between countries, look at regional differences, whatever takes their fancy. The statistical package R is more complicated, but for those that are interested, it basically allows them to be introduced to the kind of modeling software that an epidemiologist would use. And then the final project is original research. And this is basically for a student or a small team who have got their own questions. So they're not following any of the projects that we're offering, but they might have something that they're particularly interested in. So the project is arranged with a number of guidebooks that help them to basically think about how they ask questions about how to do background research, and then support them through their own research project until they can make a final artifact, whether that be a poster or to write it up for publication. And in that regard, not just for original research but for all of our projects, if you have a student who has a project idea which is perhaps suitable for publication, that might be in a blog, it might even be in a peer-reviewed journal, then we do support students one-to-one in state schools to enable them to take their research and to get it out into basically communicate it beyond presenting at one of our conferences. So those are my projects, and now back to Katie.
Thanks, everyone. That was great. I'm just going to talk through now where all of the project resources are held. So those of you already registered with IRIS, you will have a login for your school to access our resource centre. This can be found from our main website. It says login, and you'll see then a place to put your password and your login details. If you haven't yet registered with IRIS, your school will be issued one of these once the school agreement's signed. The login you're given isn't an individual one, it's for your whole school. So you can share that with other staff members running projects and with the students themselves. It's of course up to you how you lead it, but we encourage students to be student-led in their research so they can work through the resources at their own pace. So on the resource centre, when you log in, you'll see this screen on the right with this little menu icon at the top. When you click on that, you will see a list of all the projects. So if you're browsing to pick a project, that's a great place to start. Once you know which project you're doing, you'll find all of the resources on that page. So you'll click on it and see a page like this middle one. On the left, it goes through each project phase, which I'll talk through in a moment. And you can also find other things like places to upload work for review, for your posters ahead of conferences, videos, lots of information, everything you would need to know. I'm going to now show you the phased structure. So as you'll have heard, the projects really vary across all the different subject areas and the way that the students work on them, whether it's a wet lab project or an online project, but they all follow this structure. So in phase 1, this is really about giving teachers information they need in order to run the project. So we have an introduction booklet. In that, you will find information about any materials you need, any software you might need to liaise with your IT department about. We also have a student registration form and some surveys in phase 1. The student registration form and the surveys are really important to us as a charity. We really need to know how many students, what age they are taking part, and it's really important to track what impact our projects are having so that our funders can continue to keep everything we're doing free for schools. Phase 2 is where the students get started. So every project has a phase 2 background reading booklet. In some of the projects, this is fairly light touch, and it explains a bit about different sources of information. It might signpost how a student would read an academic paper. We recognise this would be a whole new thing for them to explore. In other projects, there's quite a lot of training involved. So we talked about Python and other software used. So within this, there might be training packages so students have all of the skills and knowledge they need to be able to confidently ask their research questions. So phase 3 is where the research happens. This is the students conducting their research. And then phase 4 is them communicating this. So closing the loop on the research cycle. We encourage all students to make an academic poster, either as individuals or in small groups. And then they're welcome to bring these to the conferences. I'll explain more about that in a moment. But as Richard said, for some students, writing up an article is the right way to go. Others might really want to do some kind of presentation so they can share it with other students at the school. We can support any of those kind of pathways they're interested in taking. So I mentioned at the beginning that the projects are sort of designed to launch in the autumn and wrap up for our conferences in the summer. But you can see here there's a really big scope in how you want to run this. If it's not feasible in your school to start a project until the spring term, then we can absolutely enable that to work. You might want to carry on into the next academic year. That's absolutely fine. There's also no requirement to bring any students to the conferences. That's purely an optional extra. So on to our conferences. So at the moment, we host these in June each year. And it's really like an academic conference, a chance for the students to showcase their research posters, hear about other students' work, and also hear from more established research, some of our partner researchers or early career researchers. So all students coming to a conference must have been involved in creating a poster so that they can actively take part in the poster sessions. And we print these out and display them all, and then the students or the schools can take these home afterwards. So we're currently working towards these dates for the conferences in 2024. I should note these are really only tentative dates. We haven't booked any venues yet. So we're looking at something like Exeter on the 18th of June, Manchester the 20th of June, and then London the 25th. More information about this will be announced in the spring term. So we send a month ahead newsletter out early each month with news of events and webinars. So look out for that in the spring term. Registration period will open then. You can tell us how many students you want to bring. There'll also be information about our bursaries for state schools. At the moment, we're able to offer up to £500 per state school to go towards travel and also staff cover costs. I've just started playing a video there, which will hopefully give you a bit of an insight into how it really feels to do an IRIS project.
Real research is so different from being sat in a classroom or a lab where somebody is going to tell you what the right answer is.
I was actually blown away by how much research they did and how much they've learned from it.
It's huge for them.
Oh,
it's an enormous opportunity, and they're doing so well.
I think it's been really brilliant for the pupils and me at the same time, because I've been learning at the exact same time as them.
Yes, I mean, it's without doubt the best part of my job.
And actually, if you give the pupils the tools, they'll do it themselves. A successful project, they run it. You don't run it, they run it.
Research is like everything which moves our community forward.
Rather than just learning theory, you can actually apply that knowledge to something and you can see why you learn it.
I went into it almost knowing nothing about my own condition, and now Towards the end of the project, I know so much more.
It helped me to understand what I want really to do in the future.
It makes you work yourself a lot more, which probably will be doing a lot more in the future years.
It's prepared us for the future, so like when we go into university in the future, it's going to help with research we do there.
It makes you enjoy wanting to come to school.
It brings on your other studies as well.
It's allowed us to expand our knowledge, learn a lot more outside of school, and work as a team.
There's no curriculum. There's no bounds really.
And I think it's fueled a greater passion for research, which we obviously couldn't get through our curriculum.
Obviously, it's been a lot of work with my A-levels as well, but I'd still do it again.
I thought I couldn't do it at the start, but I stuck at it and I really enjoy it now.
Yeah, I'd definitely say just go for it.
It's really nice to see these students who are totally fired up about STEM, about physics, about the careers they might have ahead of them.
It's a really good way to understand the world around us.
Right now, scientific literacy is more important than it has ever been.
The more people who can do science and are doing science, the faster we make progress. So why not?
So thank you for joining us today. Hopefully that was a nice flavour of what our conferences feel like and what the students and teachers think about the projects they're doing. If you have any questions, you can email us at info@researchinschools.org or reach out to your regional lead. And we really look forward to working with you.